Hello everyone. Sorry
Good
about
morning.
morning. Sorry about a bit late. I just finished another meeting. Um okay, so let's just start it. I think today we continue to talk about the IP, right? As I mentioned, this is a very important concept in the networking class. So I hope we can cover it as much as possible. Give me 1 second. Let me share my screen. Also, I want to configure my. Uh, okay, I want to configure my screen. Okay, so so I think you should be able to see my screen, right? Okay. Um, I think last lecture we were talking about IP datagram format, right? Have different components here, different necessary information in the format as we have already seen the HTTP format, right? TCP format, different protocol have different format. And as we also saw before, for the different layers, they need to encapsulate their own data unit, right? So here for the network layer, right? This is network layer. This is a datagram format, right? Previously we have the packet, right? We have the packet unit, so they have to encapsulate and decapsulate, right? Anyway, this is we have already explained that. Okay, let's see. Overview of the IP addressing. So, I mean, before you start learning this class, when people are talking about um, computer networks, right? Something may appear in your mind, and I believe most of you may think about, okay, so I use a web server, I use a browser, I input a DNS, I input IP address, right? We have already explained the DNS, right? So domain name server service. So you just convert or translate your IP address to your domains, right? Domain name that you can remember clearly, right? But then we need to go to the lower level or lower layer, right? So we don't have a DNS assume, right? So if we only have something called IP, right? How you use the IP address to access, right? How to addressing using the IP address. So here is the key component about the IP addressing. So general speaking, IP address is a 32-bit identifier associated with each host or router interface. Okay, so here is a definition. If you are using the IPv4, right, the IP address is a 32-bit. You can see a 32-bit 011001, right, something like this. And here is a typical IP address, right? Something like this, 223.1.1.1, right? If you convert that into a binary format, that would be 32 bits, right? Because every here is every 3 bits. Here is this is not a bit, right? So it's two, I think up to 255 would be 8 bits, right? So you can see there are uh four parts here. So totally there would be 32 bits, right, for IP address. And as I mentioned here, the each IP address 32-bit identifier associated with host or router interface. Okay, about the interface, so it's a connection between the host router and the physical link. The router typically have multiple interfaces, and the host typically has one or two interfaces. For example, the interface with um, sorry, I think the interface with wide Ethernet or wireless, right? Here is the IP address. I think the order of the animation has some problem. Anyway, I should be first showing the IP address here, right? You can see there are 32 bits, and each bit represent a number in a decimal, right? So if it's a decimal, that would be between 0 and 255, right? So 8 bits can represent 0 between 0 and 255 to 256 numbers, right? So you can think about if you use all the bits here, how many numbers you can present, right? The 2 to the power of the 2 to 32, right? Or 256 times 256 times 256 times 256, right? So 256 the power of the 4, right? So anyway, I mean, here is a we will talk about that later. So if IPv4 is not enough, what should we do, right? We have the V6, right? We have a different IP address format. But now, if we assume that we are using the traditional 32 bits, so here is the format or notation. Okay. So about the interface. So what are the interface actually connected? So we will talk about the interface in the later chapter. But you don't need to worry about that. Generally speaking, you have the different physical layer, right? Physical link, it has a wired Ethernet interface and the wireless Wi-Fi interface, right? Connected by the Wi-Fi base station. So for now, we don't need to worry about that, how one interface is connected to other. Okay, we will talk about that later. But now we just focus on the IP, how do we use IP address to do the addressing, right? So let's see something about the subnet. This is the before you fully understand the how IP forwarding or addressing, we need to understand the subnets. So what is a subnet? So what is a subnet? So subnet is a device interface that can physically reach each other without passing through intervening router, right? So I think the idea is that if you have some LAN, right, some local network, you don't need to use a router to pass the message or communicate with each other, right, within this local network, right? For example, you can see here we have we have three hosts connected in the local network, and they have two, right? You don't want to, if this host want to talk to this one, you don't want to go through the router and back to this one, right? Or any other path, right? You want to directly talk to this host directly. We want to use the router only if you want to talk to some device or host are not in this local network, right? So it's like a hierarchical I mean mapping, right? So you don't want to do everyone in the same network, and sometimes it's not possible, right? You have some local network within your home or organization. Okay, so the IP address have the structure. And for the first several or tens of the bits, it would be the subnet part. The devices in the same subnet have the common higher order bits. So what does this mean? I will show a figure. But generally speaking, you have 32 bits, right? So the first part, for example, 24 bits would be shared. I mean, not be shared. I mean, the device within the same local network will share the first 24 bits. Okay, and the later 8 bits would be the part for the host. Okay, so I will give an example how you can use this mechanism to quickly identify which device would be in the same local network or not. But general idea is that if the two devices share the same part of the subnet, right, or subnet part, they are in the same local network. Okay, and for the later bits, that would be the different for the different host parts. So okay, so why we need a sub network as we mentioned, right? We can detach the interface from its host or router, so create islands or isolated network, right? So you don't need to talk to the router interface. You just detach from them. You have the isolated network here, local network, as I mentioned, right? So for this figure, we have the three different subnets, right? Because you can see here, we have the 223.1.1 and the .1.1.2, right? .1.1.3, right? You can see the only last uh, bit are different, right? And for this one, also the same thing, right? And for this one is the same thing. So there is a key concept we will introduce here. But before I introduce that concept, someone may have already guessed that you need to identify, right? You need to give some information about from which bit, right? The device would be within the same local network or not, right? So for this case, my point is here, so only the last bits is different. So for the first 24 bits are the same, right? So as we mentioned in the last slides, for the first 24 bits, for the subnet part would be the same. And for the host part, right, only the last 8 bits are different. So we should have some information here, right? As indicate as a 24 or 8, right? To distinguish that if you want to identify the device within the same network, you only check the last 4 bits, right? The first 24 bits are the same. Okay, so anyway, I will introduce that concept later, but each isolated network is called a subnet. Let's just finish the concept here. So as I mentioned, here are 3 subnets here in this figure, okay? So we can see here, we use a new notation. So that's what I mean for the new concept. This is a new notation, 223.1.3.0/24. So the new concept is subnet mask /24. Okay, so I just repeat that /24 means the first 24 bits within the same subnet are the same. Okay, and only the later, right, or close to the end, 8 bits are different. We are using that 8 bits to identify the different or to distinguish different device within this subnet. Is that clear? So we introduce a concept as a subnet mask. Okay, so now you are using this notation 223.1.3.0. Okay, .0/24. This means this 32-bit IP address, the first 24 bits would be the same. So in this case, it's 223.1.3 are the same. You only change the last 8 bit. In this case, you can see we only change the last 8 bits, 1, 2. So if you, for example, in this case, if you have a /24, that means the first 24 bits are the same for this subnet. You have the last 8 bits to identify different device. So how many devices we can have in this subnet? That's a quick question, right? So this 24 is not always the fix. It can be configured by you, right? Yes, 254. I will explain that. But anyway, 255, 254 are, I mean, if we don't introduce a later concept, both of them should be kind of right? So you have the 255, 254. So we deduct 1 because we also need to reserve 1 for the broadcast, right? But anyway, my point is here, it's 24. For example, if I use 25 for the subnet mask, that means I only have a 7 digit, right? 7 bit for the subnet work, right? That means I only have a 127 minus 1, 126 something, right? So this number can be configured by you. Okay, we will introduce another notation later, but here is something I want to mention here. So 24 is set by you, right? Depending on how many device you want to configure in your subnet. Okay, so I think that's clear for everyone, right? So but in this figure, let's just assume every isolated subnet have the subnet mask as a /24. Okay, so all of them can configure the last four, last 8 bits for their network. Okay, so all of them are /24. Okay, and for the first 30, for the first 24 bits, they are not the same, right? They are not the same, but yeah, because they we will mention that because they are from the same organization. The previously some bits could be the same, right? But to be precisely, the first 24 eights for the different subnets no relationship, right? Have no relationship. They can be totally different. Okay, but within the same subnet, they should be the same. Okay, so where are the subnets in this figure? And what are the /24 subnet addresses? That's just a quick example, right? So we have the different subnets in this figure, right? And all of them, I think we use a subnet mask /24, right? So you can see here for the different subnet, we have 1, 2, 3, 4, 5. We have 5 subnets, right? Each subnets, they have the different first 24 um, bits to identify or to indicate different subnets, right? And the last 8 digits to indicate the different host devices within the subnet, okay? So if you understand this concept, we can quickly see an example, okay? So for example, if I have a ABC 3 IP addresses, and the A subnet mask is 1, 2, 3, 4, 5, 6, 7, 8, right? The subnet mask is I think it's a 8-bit, right? Oh, sorry, not 8-bit. Sorry. I think it's a 24-bit. Sorry, I didn't see that. Okay, it's a 24 bits, right? So it's a /24, the same. Okay, so here made some confusion here. So we use /24 to, but in computer storage or a message, right? You cannot have a 24, right? That 24 indicates the first 24 bits. Okay, not that IP address. You convert that binary into decimal, but here is a 24 just indicate that the first 24 bits, right? So indicate which part of the IP address, how many bits in the IP address are to distinguish the different subnets, right? So here the A subnet mask is 24, right? So means that the first 24 bits indicate different subnets, okay? And the last 8 bits indicate different devices, right? As I mentioned. Then in this example, how we use a subnet mask to identify different subnets or the same subnets, right? So if, for example, if you want to compare A with B, right? So because A subnet mask is 24 bits, you just compare the first 24 bits between A and B IP addresses, right? So you find that, okay, the first 24 bits are exactly the same, means from looking at the A and B's IP addresses, I know they are in the same network. And the last 8 bits are for the different devices. Okay.
Is it possible to go to the slide before this one?
Okay. Is that this side?
Well, the one that was showing like all the different machines. With the, yeah, I think it's that one. So like on this one, like, so they all have the 223.1. That's the same, right? But then the you know the third, I guess you call the third digits different.
Mm-hmm. Right.
I guess I'm having a hard time understanding. So what can we get out of this slide? I guess.
Okay, your question is that why the first two digits are the same, right?
Well, I understand that kind of puts them somewhere
Mhm.
where they can still kind of interconnect, I guess, right? But then that third digit is changing. I'm sorry, how is that changing things? I guess.
Okay, this is a good question, but as I mentioned, so this is something we're discussing how you allocate the address to different subnets, right? But just as mentioned, to be precisely before we discussing that part, the first 24 bits can be totally different, right? They are not necessary to be 223.1. They can be 223.1, 224.1, 225.1, right? Or maybe even totally different. I mean, if we don't introduce the hierarchical addressing for the different subnets, right? For now, so far, you just assume that the first 24 bits are different. As I mentioned in this slide, right? You can see B and C are totally different, right? Even for the first 8 bits.
Oh, okay, so we're talking about like different segments of the network, and that's kind of what you're
Yes,
saying.
yes. But I think these slides are kind of confusing because they are using the same 8 bits for the different subnets. But I think this is reasonable because they are in the same organization. Usually they will have some similar or the same first 8 bits, right?
Right. Yeah, I think I was confused about what exactly they were trying to convey with the slide.
Yeah. Thanks for the question. Yes, but as I mentioned in these slides, I think this is a good example because for B and C, they may not be in the same organization, same networking or whatever. So from the first 24 bits, they can be totally different. Okay. So the 24/24, the subnet mask just indicate that the 24 first bit is using for different subnets and the last 8 digits for the devices hosted within the subnets. Okay, so you can use the 24 bits to identify A and B are in the same subnet, and you can see C and the A are not in the same subnet, right? Even from the first 8 bit, right? They are not the same. And the second, the third, right? The first 24 bits are not completely the same. Okay. So that's why people are using the subnet mask to identify to indicate the information. So there is a question. Okay, this is a good question, Jared. So you are asking something I'm going to talk about. Yes. So 24 doesn't mean not correct. That's correct. And why we use the 22. So if you think about 22, difference between 22 and 24, what's the difference? If we are using /24, how many device we can put in same subnet, as we discussed, it's a 250 something, right? Let's not be such accurate 250 something, 54, right? Something. But if you are using /22, how many? How many devices you can get? So if we consider 32 bits /22, you have remaining 10 bits for the different devices. You can see we almost 4 times, right? Yes. So you may feel that how many bits or how large is the subnet mask will decide how many devices in the subnet. Is that true?
Right. So that's a way to limit, I guess, the number of devices we want on the network kind of thing.
Yes. So originally speaking, if people do not use this CIDR, um, right? CIDR thing. So we can only configure, for example, /24 /18, /16/8. Then you can see the how many devices within the one subnet is dramatically jump, right? So that /x give you the flexibility to configure how many devices within a subnet. Okay. If we don't have this CIDR thing, right? So that means /8 /16 /24, right? So /8 would be much more than /24. /16 is kind of larger than the /24, right? So /22 is some trade-off, right? Between them, in between them. So I think the CIDR, I hope I answered your question. So slash 22 is right? And the first 22 bits are indicating for different subnets and the remaining 10 bits for the different devices. Okay, so the subnet portion of the address is of arbitrary length, right? So because we want to give the flexibility here, and the address format is a.b.c.d slash x. X is the number of the bits in subnet portion of the addresses. So I think I should make myself clear. So here you can see slash 23, slash 22, slash 21, right? Any, depending on how many devices you want to put in the subnet. Okay. So I think if you have the different slash X and Y, definitely they are not in the same subnet, right? This is obvious because if the two devices are in the same subnet, they should have the same X and Y. So if X and Y are not the same, definitely you don't even to compare them because they are different subnets, right? So you're just directly treat them as a different subnets and what we will talk about from different subnet addressing, right? Okay. So then we have actually we have two questions here. How does the host get IP address with its network, host part of the address, and how does the network get the IP address for itself? We will first see the first question. So how does the host get IP address, right? So we are assuming that everyone has the address, but how do we allocate? How do we get an IP address for a host? Okay. So the simple solution is that you can hard code it, the IP address. For example, as I mentioned before, for the different, for example, we have the computing facility in the campus, right? So as I mentioned, HPC cluster. So the different nodes should have the different network IP address, right? For that case, we hard coded that. Okay, because this is not a dynamically join the network or I mean jump out of the network, right? They are always there. Uh, they will not be changed. So you can hard code it by the system administrator, right, in the config file. So whenever the node restarted, you will get the same thing, right? So you can see that in Unix system, there is some configuration, network configuration file there. So you can hard code it there, right? So when I configure a cluster, right, cluster have different nodes, I will check each node's IP address within the network. They are hard coded and different, right, from 1, 2, 3, 4. If I have 16 nodes, I will have a 1 to 16, right? But there is another scheme because static is not always happening, right? So you should have something to dynamically get address from the server. That's very makes sense, right? Because if you come to a new place, you join the new network, and how the Wi-Fi, how the wired routers allocate a new address to you, right? So we call it DHCP, Dynamic Host Configuration Protocol. It's a scheme to protocol to dynamic get address from a server, right? I dynamically allocate you a new address, right? That's very makes sense. It's like a plug and play, right? And how does this protocol work, right? People will have some question, or you have some question, how you make a dynamic IP address allocation happen, right? So if it's not, because people don't want to allocate the IP address by yourself, right? That's something should do by the administrator, right? But we develop a protocol here to save something efforts from both sides. So the goal is to host dynamically obtains IP address from network server when it joins the network. Okay, it can renew its release on address in use. Okay, so if you have already got that address before, so you can still use that, right? So we will talk about in the protocol, there is some scheme to check if you have joined this network before, you have already got that address before, right? If you want to use that address before, you have already got that, right? But also, you can get a new one if you are the new uh, you are the new user joining the network, right? It can allow the reuse of address, and it supports for mobile users who join or leave the network. Okay, so that's a good protocol. And if you change different building in the campus, right, or go to the market or restaurant, there is some right new IP address allocated for you. So for the DHCP overview, the host broadcast the DHCP discover message. So we will show a figure later, but general scheme is that the host broadcasts the DHCP discover message because you join the new the network, right? And the DHCP server responds to offer a DHCP dynamic address to you, right? And the host requests IP address, the DHCP server sends address, right? It's like I join a new group and I first ask the group leader, is everything fine with me, right, to join the new network? And the group leader saying, okay, you are fine. And then I request my new badge or ID, right, from the group leader. The group leader allocate a new group ID for me, right? It's like this scheme. If you have already joined the group before, but you later you leave the group and you rejoining, you just tell the group leader that, okay, just give my previously ID to me, right? I just use that. So this is like something, yeah, similar when you join a new group, right? But this is a DHCP protocol. We will show some detail, but I think this is not complicated. Okay, so DHCP client server scenario, when new device join, so you need to have a DHCP server there, right? Like a DNS server. A DNS server just we talked about before, right? How you manage the DNS with the IP address, right? So here is a DHCP server. And for this DHCP server, you can see it will be correlated with the router, okay, serving all subnets to which router is attached. It's co-located with the router, right? And if there is a new DHCP client, just a new host join the network or arriving, right? You try to connect to the Wi-Fi, right? And the router identify that, okay? And it will, what will happen? So the arriving client will first, as we mentioned in the last slide, right? Then the arriving client will need to first broadcast. Is there any DHCP server out there, right? So can I get any dynamically allocated IP address? You will first just ask, right? I'm fine to join the network. Is there any DHCP server? I can get a new IP address. Okay, so you will send a message, and you can see this is a source IP and destination IP, right? You have some transaction ID, whatever. And the DHCP server mentions that, replies that, okay, I'm a DHCP server. Here's a IP address you can use. Okay, so we will send back reply to you and give you the IP address lifetime. For example, here is a 1 hour, right, to 3060 seconds. Okay, just a reply to you. And the two-step above can be skipped if a client remembers and wish to use the previous allocated IP address. As I mentioned, if you previously you are the member of the group, you were a member of the group, you don't want to waste the time to say hello to the group leader, right? You know that there is a group leader here, like a DHCP server. You just skip the first two steps and you just request the IP address you used before. Okay, so you got the IP, you send the IP and got the IP. Okay. So yeah, I think this is a quite straightforward protocol. Okay, it's a much, I think, simpler or easier than what we learned for the TCP. Yeah. Any question?
How
Yeah.
yeah, how does the client know like to send the to 255 to like, how does it know to send it there?
Yeah, because you connect to the router, right? So as I mentioned in the last slide, the DHCP server correlated with the router, right? So when you connect to the network, it will let you arriving clients know who you should talk to and where is the HCP service address, right? So there is some information recorded in the router side.
Oh, okay, so it's provided by the router when you connect to it.
Yes, right.
And how does like this 6.7 and 6.8, how does that come into play? Like, how does it know to put the common 6.8 and?
Oh, you mean this is a source IP?
Yeah, how does it come up with like the 68, like just randomly or?
Yeah, I think it's randomly, right? Before you fully get your final IP address, it's just randomly here, I think. Yeah. And after you get the new IP address, this source IP address will be changed, right? Yes. Yeah. Okay.
Thanks.
Yeah. Thanks. Yeah. Okay. I think this is a DHCP protocol, and something here for some notes. The DHCP can return more than just allocated IP address on subnet. It can address on first hop router for client, name and IP address of DNS server, network mask. Anyway, this quick note. I think there is also an example here. Okay, this is a good example animation. So yes, as I mentioned, the router with DHCP server built into the router, right? Sometimes you just build everything to the one device, and you can see here DHCP. Okay, here's more details how you implement the DHCP, right? So DHCP protocol sitting above the UDP protocol. Okay, so once you connecting your laptop, the laptop will use the DHCP to get IP address, address of the first hot router, address of DNS server, right? So here I think is something you need to know that the DHCP request message encapsulated in UDP. Right? You can think about you implement, right? Every protocol need to be implemented, right? So we know that the IP and the UDP or TCP, right? How or where you implement DHCP. So here give you more information about the DHCP is sitting above UDP, right? So you can just implement that based on the UDP protocol and encapsulated in the IP and encapsulated in the Ethernet, right? It's like some, I think sitting beyond the UDP and TCP is something like HTTP, right? So that's layer, okay? And another thing, the Ethernet something, we will talk about that later, okay? Just reply. Yeah, anyway, I think this is something uh, we can understand after we learn some Ethernet thing. But just to remember the DHCP as it's kind of protocol sitting beyond the UDP layer. Okay. There's more details. Just a reply back. Okay, decapsulated. Okay. Anyway, yes, I think we can just let me see how much time do we have. Okay, we have 10 minutes left, so let's just finish this part. We learned that how host can get IP address when joining the new network, right? And how does the network get a subnet part of the IP addresses, right? So it has to be from the ISP address space, right? So the question is that when you join the network gives the host IP, but what is the, as we discussed, what is a 223.1.1, something like that, right? How we get that IP address? That should be based on the ISP internet service provider side, right? So how you can get the network subnet part of the IP address? The answer is that get a located portion of its provider ISP address space. So here, for example, the ISP block, we have the first, I think is 8, 8, 16, 20, right? The first 20 bits, the ISP block tell you that, okay, the first 20 bits you can use, you have to be the same, right? For your uh, organization, right? So the ISP told you that this eight, and this 4 bits, right, has to be the same, right? Because you are from the same organization, or you from the same university, you have the different sub organization here, right? And then we just change. So that's why, as I mentioned, it's realistic to assume the first some bits are the same, because the ISP, internet service provider, ask you to use only give you the flexibility or option to change the later part, right? But fix the first 20 bits, because it can direct the message to you, right? After that, you just allocate different subnets, and you just use that by yourself. Okay, so here we can see that we can ISP can then allocate all its address space in 8 blocks. We have the 16, 18, 20 until 30, right? So here is the slash 23, as we mentioned. We have the 23 for the subnet mask. Okay. And here is the hierarchical addressing. So it allows efficient advertisement of routing information. So here you can see we have the different ISP, right? So different ISP allocate the organization with a different IP address, and we have the different ISP here. So you can see here the ISP providers can let the internet know that send me anything with the address beginning as this. Okay, and another ISP may know that sending me any information or message beginning as this, right? This is managed by the ISP, right? Internet service provider. Okay, but sometimes it may need more reorg with the IP address, right? For example, here the organization one moves from the fly by night ISP to ISP RUS, right? It just move the organization from one to another one, right? And after that, so in the future, this IP address would be, managed by this ISP, right? And then if there are any address starting with this IP address, just forward to this ISP provider. Okay. Okay. I think that's it, right? Okay. Let's quickly see another topic. This topic I think is not difficult. We can quickly cover that. So the network address translation. So what does this mean? Why we need to translate the IP address? So what we discussed before, what we discussed in the previous slides, we have the local network, right? And as well, we will have some rest of the internet, right? So for the local network, is the datagrams with the source or the destination in this network have some same addresses for the source and destination, as we discussed, right? And all the other datagrams leave the local network have the same source of the NAP address. So what does this mean? So you can see that in the same local network, you will have the same maybe 24, right? As we mentioned, 24, 23 bits are the same, right? They're from the same subnet, but outside world are totally different, right? So how we can translate the IP address within the local network and the outside of the network? Then we need to have some network address translation scheme here, okay, to address the IP address outside world. Okay, and the idea I think is that all devices in the local network have the 32 bits addresses in a private IP address. These are not public accessible, right? So only the local network knows that. and they have the same prefix, right? And it can only be used in the local network. Once you need to go outside world, you need to convert or translate your local IP address to something public world can know that, right? As we are the same group of the WSU students, we have the WSU ID, but we also have the University of Idaho students. They have the ID system, right? How we can talk to each other just using the ID, right? So then if you want to know the people in the other university, our university may need to translate your ID into something that the outside world can recognize, right? And when you receive a message, you need to translate it again back to some ID within the WSU ID knowledge, right? So that's the general idea. There is some translation work here. Okay, so advantage is that why we need to do this work. So that's because of just one IP address needed from provider ISP. So you don't need to know because, for example, University of Idaho, Idaho, they don't need to have a database to record everything within the WSU student system, right? They just need to find our maybe student center, right? Some stuff there, and the staff there can look into or identify our student within the university. Okay, so you just need a one IP address for the from the provider ISP for all devices within the subnet, right? You don't need to give a lot of IP address, and you can change the address of the host in local network without notifying outside world, right? You can just change your IP, your ID address within WSU, but you don't need to let other university know, right? They can just ask our staff to find you, right? So we just have one same ID for our university, right? So I think when we submit the proposal, some funding project to the NSF, National Science Foundation, we use the same ID number for our university. We have the ID. Actually, we have the ID for WSU, right? We can use that ID when we submit some proposal, we submit something, right? But how identify our faculty? Just look into our university's directory, right? So that's some scheme, same scheme, and also can change ISP without changing the address of device in local network, and also because of the security thing stuff. I don't think I have time to continue more, uh, but I think this animation just to quickly expand what I meant, right? So you have the local thing, when you pass the router, it just translate that and let outside world know that. When you receive something back, you just translate the IP address back, okay? But we will give more details here next lecture, okay? So anyway, this is today's class. Any question before we close? So I didn't cover all of things for NAT. If you have question, we can, we will, repeat that again, but just give you some idea before next lecture. Okay. So sorry, I didn't upload the slides. I forgot that, but I upload the video. So I will upload the slides today. Okay, and I think for the assignment 3, TA is grading that, and some students still working on that. But as I mentioned, because of the fairness, I will deduct the penalty, but it's better than not finishing them. Okay. Okay. So any question? So if no question, thank you everyone. Okay, thank you everyone. So see you on Friday. Happy Wednesday. Bye bye.